Action.
If you're at school, I'll probably just put it up on the screen because I'm curious what they're going to say. So they'll be playing in my room. But, the orientation is locked. This is annoying.
Bob.
Is annoying also. But not where I was going with that. Okay, so.
You get the reference, right? It's reference Cat in the Hat.
Okay. Oh no, it's not on the screen. Struggle. Hi Joyce. I'm trying to get the mock AP up on the screen so we can keep on going over questions. You guys have also, it'll be on my desk somewhere close. I've also just gotten the 2012 AP Calculus BC exam. There are good questions in it. I'm not necessarily sure that all of them are indicative of all the questions you're going to see because this practice exam that you guys took is very unique in lots of ways. Like that definition of the integral problem, I've never seen one of those put on an AP, but they have said that they want to test concepts more. So it's not that they've added anything to the AP curriculum, it's just that their questions are going to be a bit more conceptual. And that is one of those ones. And like an AB, there were a couple this morning that when I was going through with them. Actually, maybe it's a good idea for me to show you theirs also. Because some of the questions are the same, but some are different. And there were some conceptual ones also that I was like, oh my goodness.
You wanted me to put a star by it? Number 21.
Let me see. I don't know. Did we do number 21 yesterday,
We
guys?
may have.
You told me to put a star by it, and I wasn't here yesterday to tell you there was a star.
Oh, we did. We did do it.
Did we finish all of those questions?
We skipped 87.
Oh, that's true. I went to a fast one. Huh.
Yeah.
Oh, Georgia, I figured out what was wrong. In my head, I was visualizing the area under tangent, which would have been the same on either side, but tangent is the antiderivative. So I was visualizing it incorrect. Secant squared is always positive. Does that make sense? Yes, that would make
Misty, will you go to 90 really quick? I'm just going to.
Yeah.
Did I didn't write it down. That's great.
Oh, I just
Oh,
made
it's
it.
at the end of the time. Wait, isn't it?
Number 90 was the last one that we did yesterday. We didn't spend tons of time on it. The long story short of it was they told us conditionally at 5. This is the at 5, right? At 5, and this is the at -4. At 5, we know that this one converges conditionally, and the only way that this can converge conditionally is if we have an alternator in here, right? Because the 4 to the n does not have an alternator. So we have an alternator in the a to the n, and then somehow we have something that's approaching 0 faster than 4 to the n. So it must have something greater in the denominator. So then when we look at -4, if this term has an alternator, then this one right here, we're going to have a -1 to the n times 5 to the n. So it's not so much the 5 to the n that causes us a problem, it's another -1. And so if we put those together, then the alternator with another alternator would become a positive, and that's going to, if it only converges conditionally, the positive is going to make it diverge. Does that make sense?
Yeah.
And that's how we got to that one. Okay, we skipped a few though. We skipped.
Did you guys do 80? There's a lot of the video.
No, we did not do 80, but it was a question. It's a question with a graphing calculator too. The total area, let me get a picture of that, except the graphing calculator's over here somewhere. You guys have your grapher?
Yes.
Alright. Let's see. Polar mode, check. What are my two polar curves? We have 5 sine of 3 theta,
Oh, yeah.
and we have 8 sine of 3 theta. So we have 2 different flowers, right?
You have the wrong formula. No, that's the thing. I divided by 2, and I got it right for some reason. I couldn't figure out why I'm supposed to divide by 2.
Oh, I multiplied by 2, I think that's what it was.
No, I did the whole, I did all the integrals, and afterwards I'm like, on a hunch, I divided my answer by 2, and I got C, and I'm like, why did I divide by 2?
Well, isn't it part of the formula? That's 1/2.
Yeah, no, I had the 1/2 in there.
I'm pretty sure that it doesn't need 1/2. Or it doesn't even actually divide by 2.
Are you kidding me?
the world did I get A?
How many batteries die?
How did I get that? That's the real question.
Maybe you just went like, I forget.
So they have the exact same angle because it's graphing the exact same part. So that's not a problem. Sometimes the angles might be different, so that's why I have it do simultaneous
get?
graphing.
Would you guys, no, but would you guys get a 0
D. Oh, 0 to 5.
Okay. I did 5 with 3.
I did 0 pi with 3.
Yeah, I would have done 0 to pi with 2. Because it does 2 full cycles in 2 pi, so it's going to do 1 full cycle in pi, and then it's by thirds, right? What did Gerardo do?
I did 0 to 5.
Oh, you would have gotten 2 full cycles then.
Oh, that makes sense why you'd rather do that.
Because when you watch it graph with 2 pi, with the little circles, remember, get those little circles, you guys know what I mean, right? The indicators that show you where it's graphing. You would see it go around twice in 2 pi. So then, yeah, your bounds are out of whack.
That's the thing. I graphed it. I subtracted them, and I graphed it in function mode to get the zeros. And for some reason, I did 0 to 5.
Yeah.
No.
It should have been, in function mode, it should have been periodic, so it should have repeated. From pi to 2 over pi. Or sorry, pi to 2. So now we're okay, because you can just do the 1/2 and you do the outer curve minus the inner curve.
No, I still got it
Oh, you still got one? Okay. So hold on, how do we set it up?
wrong. You go first, I don't look down.
So we have, I'm going to do 1 pedal and then just multiply by 3. Is that okay?
Yeah, that's what I did.
So we can do 1/2.
I forgot the 1.
Oh,
Keep going. Maybe I forgot. Maybe I did the wrong one.
8 would be the bigger one, right?
Yeah. Right, I guess that's 1. I forgot the square.
There's no.
I did the complete wrong thing.
Double check, it's 1/2 r squared, right?
Yeah.
But why isn't it the one that's like the integral of the first function and minus the integral of the second function?
Because in my graph, you have, I don't remember exactly how it graphed, but long story short, something.
How do you know what these look like? Was that a pre-cal thing?
Yeah,
Got it.
but it's graphed in my calculator too.
But like there was one that asked to figure out what the graph was without a graph calculator. And I had no idea.
You couldn't do a table, or you couldn't plug in.
That's what you would have done. Alright. I definitely guessed. I guessed, but I got it right.
I mean, remember how there was that whole chart?
Yeah,
Like, you
okay.
could memorize that whole chart if you wanted.
Every year except this year.
Or start plugging.
Yeah.
Okay, that makes sense.
Use the inner circle. So then Georgie and these ones are trying to find the area between. So when we have this guy, he's going to be the bigger radius. So he's going to be finding this area as I go from 0 to pi over 3. But this guy is going to be the littler one, and I need to subtract the littler radius to get all the in between. Does that make sense? So you do them separately. 1/2 the big R squared minus 1/2 the little r squared. The one that gets confusing is the one that's area inside both.
That's right, and maybe that's why.
I used Blue very recently on the board before that.
Oh, that's what it was.
That's what it is. All right. What else we got?
Confirm something.
Let's confirm. Wait, guys, I have no other circles. George, do you have any more circles to add? Because we did that one.
Okay, so we just did 90, just did 80. And then
Or A, Dad, do you have any more?
did you guys do 30?
No.
25?
30. We didn't do 25. We can add those ones.
30.
Can we do 14?
Yeah.
Did we do 26?
So 25, 26, 30, and then 14. Alright. that should pretty much get us to the middle, and then we'll go to the 12. 14. There we go. All right. Let me get my red pen ready. Let's begin.
Oh, yeah, 14.
As soon as you guys see all the multiple choice, you should think the Maclaurin, right? Okay, so then thinking about sine of x. What's the Maclaurin for sine of x?
X minus x cubed over 3 factorial plus x to the fifth over 5 factorial.
Okay, and then if I'm trying to think of sine of t to the sixth, then I'm going to have t to the sixth minus t to the sixth to the third will be t to the 18. Good, power to a power, you multiply. And then we have plus t to the,
Can't read my writing. 30.
got it, 30 over 5 factorial. And then I want to integrate, right? So to integrate from 0 to x of sine of t to the 6th dt. It's going to equal the antiderivative of x minus the antiderivative of 0.
You should integrate term by term, right?
Integration is that change. Yeah, you should integrate your factor.
Yeah, so that's
So then you have 1/7 x to the 7th over 7. And then you have, what do they do? Keep the factorial separate? Oh yeah, they do. So x to the 19 all over 3 factorial times 19. At this point, can we just match it?
Yeah.
There we go.
Perks of having this deep drive to Baja or drive you to Baja.
Until the roads got windy, then it got rough. I was surprised you hung in there as long as you did. I would have been out like the first question.
Question: how come you guys go to Baja and not Tijuana? Out of curiosity.
Because we have a relationship with a mission in Baja. And so it's not so much that we're discriminating against Tijuana, we just don't have an easy in right this second.
If I'm going to Tijuana, I'm getting lit.
Dirty?
Getting lit with Jesus.
Okay.
I mean, Jesus.
Number 25. Ooh, as soon as you see sphere increasing, it's a related rate.
Yeah, I just couldn't figure out how D and R are the same because it was rough.
That's okay. So we just have the volume, so we know that dV dt is increasing, so positive 6 pi, right?
Yes.
Centimeters cubed per hour. At what rate in centimeters is the diameter increasing? So we define dV dt when r equals 3, which would be d equals 6, if we need that clue. So that's what we want to find. Now the dilemma is we have volume in terms of radius right now. So we could go ahead and take the derivative of this guy and then make a separate equation, r equals 1/2 d or d equals 2r. What would you guys rather? Would you rather take the derivative of this and that, then put them together? Or substitute now and then take the derivative? Both are fine.
I failed both ways.
I think I plugged in later.
Okay, so take the derivative right now. So we can know dV dt is equal to 4 pi r squared dr dt. And we can know that d dt is equal to 2 dr dt. So we can say dr dt is equal to 1/2 dd dt. So then we can say dV dt is equal to 4 pi r squared times 1/2 dd dt. And then we're plugging in what?
3,
6 pi?
6 pi, 3.
R is equal to 3, so 9. 9 times 2 is 18.
Minus 4.
Sorry, 4 divided by 2.
Oh, I see.
You see what I just realized?
Huh.
I solved for D and for R, and I plugged it in, DDT.
Oh, okay, so you did the original. You would have substituted before taking the derivative.
Yeah, I just realized that.
That works. Both ways work. Is the A the right answer?
Yeah.
Wow. Somehow I put 4/3 times pi, but then I also did 3r squared. So the 3's canceled out, so it worked, but I don't know where I got either of those 3's.
That's 1/3.
I got 4/3 pi,
That's
3r squared.
4/3.
Oh, that's why then.
You were just thinking of them separately. You were like separating the constants from the r cubed, and then you took the derivative of the r cubed.
I think you just accidentally put
That's
that.
what it. I was like, how did I get the 3's? Got it.
Guys,
Oh yeah, you just derived
Frozen
it.
is coming out in 2019.
What is?
Frozen 2.
Oh,
No.
the second one. It better be as good as the first.
I don't think it can. Honestly, I don't know what they're gonna tell a story about, but I don't think it can.
Almost backstory.
As long as it's not as bad as like Little Mermaid 2.
Have you seen Once Upon a Time? It talks about it.
I've seen a couple of them. It's a good show.
So good. I haven't watched the like, newest ones.
I haven't watched it in a year.
Miss G, you know what I realized last night? Like I was so sad. Okay, so I've been recording Grey's Anatomy. Okay.
Joyce, this is a very important conversation.
Okay, I've been recording the new Grey's Anatomy. At least I thought. Turns out I was just recording all the ones. I was like, oh, I have them here whenever I want to watch them.
Oh, you didn't like go to the first one only or whatever you're supposed to do?
I don't know what I did. I think I recorded the wrong TV station.
Oh, that would do it.
So sad.
Poor guy.
Misty, I don't remember if I asked you or not, but do you watch Prison Break? Or have you seen that?
Back when it first came on, because it like came back, right?
Yeah, I just
Okay.
came back.
When
Like,
it first came on, everyone was like, it's such a good show, and then it's such a cliffhanger at the end, and you're really sad when it ends. So I was like, oh, I'll just never watch it, never be disappointed. And then it
okay.
so
Because I'm watching it right now. It's good.
I've heard it was
A guy who brings his brother out of prison because he designed the place. He's an architect,
Oh, wow.
so he like knows everything. And then he gets tattoos of everything, so he doesn't forget it. So his tattoos are like a map of everything, and like it's cool. I just started season 2. What?
So you're watching the old ones? Did you
Yeah.
ever watch the new ones?
I figured why not?
Oh, yesterday I was watching Scorpion. Do you guys remember yesterday when Mr. Will told us that the divorce statistic isn't 50%? And yesterday I was watching Scorpion and like they said it was 50%. I was like, dang it. That was really
So you're wrong.
Okay, so then number 26, the function.
impressive.
Alright, so we have f of theta. We know that it's always positive for theta greater than or equal to 0. During the time interval, particle moves along the polar curve. Okay, so that at time theta equals t. So it's like a parametric equation in terms of theta.
Yeah. So I just did
On what intervals is the distance between the particle and the origin increasing?
I did derivative and critical numbers.
Because when it says distance between the particle and the origin, it's talking about r, right? Remember, r is how far away from the pole, right? The concentric circles. So r is how far away from the origin that you're going. So it's asking when is r increasing, and so all you have to do is then find r prime, which r is equal to f of theta. So you're trying to figure out where is r prime greater than 0. So yeah, I totally agree. You would do f prime of theta. Find your critical numbers. What do you get, Georgie, for critical numbers?
3 and 1.
It says greater than 0, and less than 2 over pi, or 2 pi.
And then positive, negative, positive.
You do 0 to 1, you 3 to 2.
But the answer is.
Uh-oh, so something went wrong?
But the thing is, because when you're moving away from the pole, like even when you're doing negative,
Yeah, it doesn't matter the orientation, because it's just
exactly,
when the
so
distance is
distance is still increasing.
But r is how far, so it's not, r isn't a direction, r is strictly a measurement of distance.
Right. So if you're here at the pole, we're at the origin, and then you have like negative, isn't it going backwards? Which is still. I don't know what I did.
Wait.
You know.
The
I don't wanna
distance
do that
between
right.
the particle and the origin is increasing when R is it's like speed increasing, decreasing.
I don't know what it is.
R needs to be positive and R prime needs to be positive, or R needs to be negative and R prime needs to be negative.
Oh.
It's like speed. Because if R is negative, you're going in opposite direction, and so you need R to be decreasing, becoming more negative. Oh, struggle! I hadn't put that together before. So you do a sign chart of R also.
That's not what I did. I just did a sign chart of
But you got positive, negative, positive, right?
Yeah.
So then how do you justify D?
And not D.
Isn't it
I got D. It's D.
Oh, my bad. I was looking at the wrong problem. It is D. Money.
Oh, now you got me all justifying your wrong answer.
Sorry. Looking at the wrong answer.
Got you.
It's
Miss
like
D,
27.
that forever said if velocity and acceleration have different signs, speed is decreasing.
No, yeah, that's true. That's what I was saying. I was thinking that you needed the speed increasing, decreasing for this one, like R sine and R prime sine. Like the, what you guys graded on AB on that last one with the two trains going toward each other, away from each other. You had to know where it was and whether or not the rate was positive or negative. But I guess it doesn't apply for this one. My gut would have been just R prime, but then I thought I had to justify a different use.
And Karen talked to you because like she was a little better. There was no videos on.
Who?
Karen's it. Because there was no videos on the makeup test. So I helped her with whatever I could, and then I was like, the other ones was like, yeah, you got it.
They can talk to me, like, I have the solutions to it.
Yeah, I was like, I don't have the solutions, but I found one of them online. So don't.
But Kara was also, oh, she might be here today. She was
Oh, yeah.
gone yesterday, so we couldn't talk about it.
No, she's here today. That's something.
Yeah, that's what I just said.
Did we have any more? We had one more, didn't we? 30?
Possibly.
Okay, I think that's it, right?
I did not.
Oh, we did 30. Oh, never mind.
No, I don't think we did.
I get tricked by that every single stinking time.
I don't get it. I don't even know what I'm asking.
Well, hold on.
She's gonna go
Bound.
right now.
No. Alternating
Oh, no,
series
I do
bound.
remember
That's
this,
the endeavor card.
I remember that. I was like, yeah, I don't know alternating series. I don't know air pounds.
Okay, but pause. Now that you've been studying your forever endeavors, because you're turning in stuff to say that you're studying forever
Yeah.
endeavors, now what will we do?
It's like R sub n. No, is that? No, that's.
Make it less than the n plus first term. So use
I
the
guess I
sixth
can-
term because it's fourth degree and it's all evens. So you use the sixth one, but you have to use 3 because if you use the sixth one, you get 10. It's really hard. You're just gonna screw it
What?
Okay, so I think the word was
over. Yeah, big time. I used the fifth term, and that got me x to the 10. That got me a 10th term.
Is it a
But if you look at all of these ones, they're all odd, right? So
No,
isn't
D
that
is what
how-
I got, and that's what tricked me. D's the trick.
I'm so confused on what Ms. D just said and how that relates to what she just said.
She said they're all odd. But
But they're not, because it's 6, so I don't know what I'm talking about. My head's still thinking. How do we find the fifth term? Because it's the fourth degree Taylor polynomial alternating series less than a sub n plus 1.
So we do 5. We plug in 5 for n.
and you get it wrong.
Okay, let's just do the work. Let's see what happens. And then we can like, yeah, let's do it.
You see, there is no fifth term. This is all evens. There's a 2n that makes it all even.
What? It's still the fifth term. It's just different. It's
There
still
would
the
be no
fifth
fifth. You
term.
couldn't get a fifth term.
We're still plugging in 5. We're still getting 10. We're still plugging in 5 no matter what.
He's saying the fourth degree. Hold on, I see what he's saying. Fourth degree term is when you have x to the fourth, and you're going to have x to the fourth when n equals
Oh.
The fifth term will still
Oh,
be
yeah,
there,
yeah,
but
yeah.
the fifth degree
the
will
fifth
not be
term.
there.
Yeah, right.
The fifth degree
Right.
will not be there.
So when I was putting a sub 5, a sub 5 will exist, but it will not be the proper error bound. It'll be too high
Oh, well.
or too low.
It'd be too high.
Too low, right? 'Cause it's a
Oh,
big
yeah,
number.
yeah, too low.
You have to plug in when n equals 3, because that would be the next term.
Yeah. So the fourth degree Taylor polynomial when you have x to the fourth, n is equal to 2. So then you're looking for technically a sub 3. I understand.
So I'm so confused. Is there?
So plugging in 3. There is technically, but that's not the one that we want. Well, there isn't a fifth degree term. There would be an n equals 5 term. But n equals 2 is the fourth degree, so we only want one higher than that.
Alright, I'm just gonna get these wrong.
Wait.
Because the fourth degree Taylor polynomial right now only has 3 terms. It has a constant, an x squared, and an x to the fourth.
Okay.
So then we're finding the fourth term,
Oh, okay.
technically,
Which would be
to the sixth. Yeah.
So what's the way that you could have dealt with this a little bit? Couldn't you have expanded this series so you have a better feel for it?
Yeah.
So that would be one way of thinking about it. Because you would plug in 1, you would plug in 2, you would see your fourth degree like, hey, there you go, and then you plug in 1 more and then use that 1 more term. So then you would end up with the negative 1 doesn't matter because it's absolute value, and you plug in 3 and you get 7 factorial, and then you end up with x to the 6. X to the 2 times 3.
The question is, where do you get 2 to the sixth on the bottom?
1/2 to the 6th. That equally 1/2 to the
Oh.
next part.
Yeah, so then you have your x value.
I see.
I got it just from the 7 factorial.
That helps though, right?
Yeah.
You're like, sweet.
So I was like, I have
glad
to
we
do that.
multiple choice.
Yeah.
Sensey.
Got it.
Tricky. Yeah, I was reading it the fourth term too, but it's fourth degree.
Okay, no more calculus for the rest of the year.
Alright, I think we officially got through all of these ones. Joyce, I'm really sorry if you have questions for us to go over because we didn't go over them.
Too bad.
You can let us know.
If you pause this really quickly, you'll see all the ones that you go through.
Yeah.
Kiddos, where is this saved, which does have the explanations to all the multiple choice and the FRQ grading guidelines?
AP practice folder?
That's where I was gonna put it, but you know how I just load these on the class notes?
Class notes. We'll find it.
I think it's saved in our minds, not on the Google Drive AP class folder.
Well, no, this is gonna be saved in class notes.
No, I mean like you can't say that on the recording.
That was
Get
good.
in trouble.
That was a good one.
Dun, dun, dun. Never mind, not
Terrible.
saving it anywhere. Not exporting it as I speak. Okay, not lying. If you guys are done with your corrections, go ahead and go throw them in a tray. I'll probably just pick them up tomorrow.
You want to staple all together?
No, but can I give you a paper clip though?
I don't know.
You don't know. That's rude.
Hold on.
Get new shoes, Misty.
Oh no, I'm just well, I'm into my condo and I have more shoes in my condo. So.
Yeah, how's moving back?
Stressful.
Huh. Did you move out?
It wasn't that so much, just like my room's all in and everything.
Chappers was excited you were back there. I saw that on Snapchat.
He was just sleeping. And he was always with me. He's sad that he's in the backyard now. Alright, so if you guys are ready with corrections, turn it in. Joyce, same with you. You can put it in the tray. And I will get them back to you ASAP. But in the meantime, yay! What do you have on your desk?
All of it.
Unless you're not that
Everything.
A brand new AP. So,
Taking another fun.
kind of. That's not necessarily a final, but it is a practice one.
He's not gonna sacrifice his salary.
Yes. Where are there other practice finals that we have talked about? Practice finals, practice APs,
Online link on your website.
online shared folder. Uh-oh. Okay, there you go. There you go. If I go here, and if I go here, and if I go BC. Why am I showing this to you?
So if you practice, get extra credit.
Yeah! What's it say at the very bottom of your board?
Bonus AP.
Exams.
Practice exams. So, if you go to AP exam review, and if you go to practice AP exams, and if you see 2008, 2008, 2008, 2012,
There was AP exam on 2012? It's impossible. What is it?
wait a minute, this is not the same as your guys's. Hold on, double check it real fast.
Bob.
What's the first problem? Is it the same? Sine cubed of x?
Yes.
Oh, it is the same? Blame
So
sauce.
this for extra, can we do this for extra credit?
Yes. You can do it for extra credit. I printed it off for you, and we're going to work on this one particularly in class. You guys can also do... I think I meant to load... Because 2008, the actual exam, and 2008, the practice exam, were different. This one is 3x minus 2. And then, what's this one? Oh, come on. Yeah. So I thought that this was a different exam, but it's actually not. So let me just go ahead and remove that because then you guys won't get confused. Remove. There we go. If only there were keys. Don't worry, I have keys. They're here somewhere. Did I put them in this folder? That'd be awkward if I did. I didn't mean to.
It's funny. Actually, might get a job there. At 118.
And then I think we did 2003 over Christmas break, didn't we?
We may have.
Okay. If you guys go to Mr. Calculus group, and if you go to his website, whip it up.
Oh, that's the one where he had the answer key all wrong.
Yeah. And then, wait, all wrong.
Yeah, like the questions were all like not corresponding.
There was like one that was off.
I was like, feels a
Here we go.
Slew of them.
2012 multiple choice practice exam and answers. 2012 practice multiple choice. That's AB. BC. Let's see if it matches up. Aha! There you go. So there are all the solutions to all the problems that are.
Wait, solutions?
Yeah.
Or like explanation?
Well, I mean, he shows the work worked out, like what to do and how to get to the answers. So work with the answers. Okay, cool. So anyway, to that end, I'm taking your attendance while you guys are sitting here because we're supposed to take attendance within the first 5 minutes of class. But who has time for that?
How do you gotta know?
I don't know. If they go looking for a kid and the attendance isn't marked. All right. With that, my idea was for us to work for the next 3 days. Today, tomorrow, Wednesday. In like sections as far as let's do real time. Like right now we have 10 minutes approximately, which should be how many multiple choice questions? 5. Maybe 6. Maybe 7. Maybe. So everybody on part A, let's work together, and then if you guys want to work on your own, work backwards. Does that make sense? Because then we'll keep on going forwards in class. So you guys should get somewhere between 5 and 10 multiple choice questions done. So then tomorrow we will grade those 5 to 10 and we'll see if we have any questions.
I'll always have to.
And then we'll have another 10 minutes, do another increment, have another 10 minutes. Okay. So today is just trying to get 5 to 10 done. Then tonight, if you guys want to work backwards on B, because we're probably not going to have time to do the entire AP exam in class, but if you finish it between class and at home, you can turn in for 5 points. All right, Joyce. Have fun. See you soon.